Now that we know what polynomials are, we can start doing operations with them. So the first thing we're going to talk about is what we're going to do today, which is adding and subtracting polynomials. After this, we'll move on to the next operation, which will be multiplication. So copied on your target, I can add and subtract polynomials. And take a look at your warm-up. It's an error analysis problem. So where is their error? Where did they go wrong? Two students evaluated the following polynomial for x equals -2, which is incorrect, and explain. That means you have to write, guys, explain the error. So I'm going to give you a minute to do this. You can pause the video. I'm not going to give you a minute. You're going to pause the video and you're going to do it. And then we're going to get into today's lesson. So which student made the error? Where did they go wrong? Well, let's take a look at this. If you look on A, here they multiplied -3 times -2 to get a +6. However, you should do order of operations. PEMDAS, which one comes first? The exponent that you see of 5 or the multiplication? Exponents obviously come first. So A is going to be the error. You need to explain it in words, guys. Explain what they did wrong there. So we need to know what like terms are for this lesson. Make sure you know what like terms are. If you need to write it down also by your warm-up. Like terms are terms with the same variables and the same exponents. So make sure you know that. They have to have the same exact variable and the same exact exponents. If I have 2x and 5x, those are like terms. However, if I have 3x and 4x squared, those are not like terms, okay? Have to have the same variable and the same exponents. When we're adding and subtracting monomials, all you do, guys, is look for those like terms. So look for the terms that have the same variable, same exponents. And again, I'm going to write that down. I want you to write it down. Same variables, same exponents. That's what you're looking for. Make sure you have that written on your note guide. So for this first one, for A, we can see that 12p cubed and a positive 8p cubed have the same variable with the same exponent. They can be added together. So we're going to add this together to give you 20p cubed. The other term is not like with them. It's different. So I'll just tack that on at the end. It's a plus 11p squared, and we added as much as we could. That is your answer. So you will have to decide how far you can go on these problems. You might be able to get it down to a monomial, one term, or you might have to keep it at a binomial or a trinomial. That's up to you to decide. Take a look at B. B has two variables, but don't be scared. Look for the terms with the same variables and the same exponents. So when I look at this, okay, I see this 10m squared n. What else has an m squared n? Does this one? No. That is an mn squared. That's different, right? M is squared here, n is squared here. So that's not like. Does this one match? It does. So I'm going to underline that. Notice, guys, how I'm underlining the sign that's with that term because you don't want to lose that. And, in fact, even this last one can be combined as well. All you have to do, guys, is add the coefficients. So think of doing 10 plus 4 minus 8. And then you're going to keep the variables the same. So what's 10 plus 4 minus 8? 10 plus 4 is 14 minus 8 is going to give us 6. That's your coefficient then. And you keep the variables, m squared, n. Just because it looks harder, think about how you would do it if you had 10x plus 4x minus 8x, right? You would have 6x. You keep the variable, but you change the coefficient. The last term is not like with anything, so we just need to tack it on. We don't want to lose it. It's still part of the expression. All right? Well, we're going to put parentheses in the problems. That's all we're going to do. We're going to change it now to polynomials. Instead of just having single terms, what if you have a binomial on a trinomial or a trinomial on a trinomial? I want you to really think about this. Do the parentheses matter here? Do you need the parentheses? For addition, no. Okay, so for addition, no. Are you going to need them on the next problem, guys, for subtraction? Will it make a difference if you have parentheses for subtraction? Yes. Okay? So if you're doing an addition problem, we really don't need these. If you want, you can just look over them or you can cross them out because they're not really going to make a difference here. However, for subtraction, they will, and you cannot cross them out then. So again, you're just looking through this addition problem. We want to add the like terms that we have. I have a 4m squared and I have a positive m squared. Together, those make a 5m squared. My next term that I would want to write, if it's in standard form, would be an m. Here's my m right here. There's nothing like to add to it, so I just have a minus m. And the last term would be the constants. So I'm putting it in standard form. That's as far as I can simplify it right now. Try the next one. Try B. Again, parentheses don't matter for addition, so just look for those terms that have the same variables and the same exponents. Make sure you keep the sign that's in front of it. So here I have a 1/2 a squared and a 3/2 a squared. 1/2 and 3/2, guys, gives you 4/2, which is 2a squared. I have a positive b and a minus 4b, so I get a negative 3b. And the last one, I have a positive 2 and a positive 5, which gives me a plus 7. Okay? Pretty easy so far. They will get a little harder. Remember, when you're adding, only add like terms. Keep the signs in front of it. All right, subtraction. Now these parentheses matter. If you just drop those parentheses, you're going to be in big trouble because this whole thing is being subtracted. So what do I have to do with that minus sign? Guys, you have to give it to each term. It's like distributing a -1. So make sure you take that minus onto each term. And I want to see this written. You don't have to rewrite the first if you think you can look at both lines, but I'm going to here. So I have 7m to the 4th minus 2m squared. But I'm going to distribute this negative. So it becomes a minus 5m to the 4th. Minus a negative becomes a positive 5m squared. And minus a positive 8 gives me a minus 8. You have to distribute that, guys, or you're not going to get the right answer. Now look for your like terms. Look for the highest degree to start with. M to the 4th is my highest degree. I can combine these two. Then I have m squared terms. I can combine these two. Watch the signs. Circle those signs with it. Positive 5, negative 2 gives me a positive 3, and then I keep the variable. And then the constant, you just got to drop it down, so minus 8. Try the next one. Pause the video for a minute and try the next one, and then check your answer. So here I'm going to distribute this negative to give me a negative x squared, and then a minus a negative 9 gives me a plus 9. So now this is what I'm actually combining, this and this. So I have a negative 10x squared minus 3x plus 7, and then minus 7x squared plus 9. Looking for my like terms, I have a negative 10x squared and a negative x squared, which gives me a negative 11x squared. Minus 3x doesn't combine with anything, pull it down. And then a plus 7 and a plus 9 gives me a positive 16. Again, guys, answers in standard form. Check to make sure you don't lose a sign or make a math error. Last example then that we're going to do together. The profits of two different manufacturing plants can be modeled as shown, where X is the number of units produced at each plant. So they're saying this represents how many units the eastern plant produces, and this polynomial represents how many units the southern plant produces of each plant. Write a polynomial that represents the difference of the profits at the eastern plant and the southern plant. So what does difference mean, guys? It means subtraction. So I'm going to do the eastern plant minus the southern plant. I might line these up separately. I might line it up vertically instead. So I'm going to have the eastern plant minus the southern plant. And look at those parentheses. You cannot forget them, guys. You need them. They make a difference. Whoops. So I'm going to distribute. I'm going to rewrite this just like we did with our systems. I don't want to try to bob around this and make it messy. I'm going to keep it nice and neat. So I'm going to keep the first equation the same. Make sure you're writing it down with me. I do want to see your work. And then the next equation, I'm going to distribute that negative. So a negative times a negative makes a positive. A negative times a positive makes a negative. And a negative times a negative makes a positive. Now, guys, I can just add up my rows, which is really nice. So I'm just going to add straight down these together. Add the x terms together. And add the constants together. There's your answer right there, guys. All right, I want you to try the challenge and extend on the bottom of your page. That's going to be part of your homework that I want to see tomorrow. Thank you.